Introduce him.
Dr. KUMARAN is a practitioner from Chennai, and he has a one-man hospital, and he has really followed all the principles. I think a lot of us don't have a lot of free spirit thinking in designing a facility now. That's what it comes to, because without accreditation, insurance does not want to pay you. Accreditation is not possible if you don't follow certain norms. If you're building a building, you have to get approval from the fire service, you have to get approval from all the other authorities, pollution control board. They don't give if you don't follow certain norms. I think the days are gone when you can go modular, because you need a minimum, like what he said about the price, minimum 1,800. There is a minimum size and scale you have to build today. I think Kumaran has done that extremely well. We have heard him a couple of times earlier. So we thought, I think Arun had thought that this is a good experience for all of us to listen again.
Good afternoon and a warm welcome to one and all. At the outset, I'd like to thank AIS and Dr. Arun Sethi for asking me to come here and share my experience with you. And thank you, Dr. Arvind, for the introduction. It's indeed a great privilege to be speaking among people like this. And this is basically my experience on what I went forward to build up an eye hospital. And this is more from shifting from a Goliath to a David structure now. So initially, why did I want to upgrade my structure? See, I just inherited my practice from my father, who used to practice in a 1,000 square feet area. So those days, see, people don't even provide a basic facility for patients to sit. But nowadays, things are changing. So the concept is, so attract your patients with your looks and retain them with your service. So if you don't have the looks to attract them, and it's be very difficult. So basically, in our older facility, we didn't have any facility for parking. We didn't have the norms for fire exits, disabled-friendly toilets, and so on. With all the accreditation coming in, whether you want it or not, it is mandatory to have all these places, all these structures in place. So with this motive, we went ahead. See, for any small-time practitioner, either a single practitioner or a group of practitioners, the major limiting factor is the space, the finance, and the time. So when we don't have any other alternative source of finance, you really have to construct your place, keeping all this in mind with the facility running. So we did face a lot of difficulty while renovating this. We did shut down our theater and shift it to a multi-specialty hospital. We did run our OPD all these 2 years when we structured. So this talk is based from a clinician point of view of how he went ahead to build this structure. And as my previous speakers had put it, building an eye hospital is a major exercise, and the main concern should be only for the patient is safety, and of course the doctor's point of view should also be kept in mind. And whatever you build, always try to follow the local mandatory licenses, the scope of services. If you don't follow, you will end up with legal litigations, and you'd always be scared throughout your practice whether something's going to happen to your structure. So always plan all the requirements in place. What is the minimum area required is a very difficult question to answer, and as a single practitioner or a group of practice, plan everything for 5 to 10 years from now on. How much of patients you want to get, what is the location, whether you want to set up a single ophthalmic practice or a comprehensive ophthalmic practice. So all this has to be decided initially so that you could design your OPD, the structures of the toilets and the theater, everything. And always have future plans in mind so that you can always extend later. So the main principles to be taken, see, a lot of time you will find yourself traveling in the right direction, but in a totally different road. You'll never know. Only when you arrive at the destination, you'll find that you are in a totally different place. For example, you finish the RCC structure, then you call the fire engineers or the HVAC engineers. They say you have to break this and break that. So it's very difficult. Have a plan before you venture into the project. Keep on planning continuously with the architect, and only then it will be helpful. The major factors which we normally neglect in a smaller setup is the HVAC system, making toilets which are differently able people, restrooms, and emergency exits. So understand that though you being the captain of the ship in a single specialty place, it needs a multidisciplinary approach. Involve as much as architects, biomedical engineers are possible. So yourself as the captain of the ship has told you, involve all these structures, and the ultimate aim is the making the facility patient-centric. So this is the main area which you should concentrate on, the patient. So, I mean, this should be very easy for all architects here, the engineering approach and the ergonomic approach. The engineering approach is the technology-centered and puts people to fit in. The ergonomic approach put people first and fits the technology around it. So a simple example here, the chair on the right does the job well. A patient can sit there and he can also work. But look at the chair on the right. The user is very comfortable, he's happy, and he can do all kinds of work on that, and so resulting thing is that he's more so efficient. So this is what the latest technology should be. It should be ergonomic design and people-centered. So how do we bring this here? So I've given a small example of what we did for it. So this is my consultation room. Sorry for the pillars in between because this was a renovated building. So I wanted to sit at that one corner. This is the southwest corner according to Vastu, and I put my patient here. So now, how do I going to design my table? So it has to accommodate me, my patient, my attender, and also the pillars in between. So what we did, and we designed a table like this, and I should thank you for my architect to design this, and this is what we got. So this is what I say. You put the people and the patient in there, and then you design the technology around it. So this is what I'm trying to say. Your ultimate aim should be the patient. And once you make the patient happy, he will recognize everything you have done for him. So the points to be considered are the present and future needs, the volume, the restrooms, the plumbing, and the different zone as Mr. Israel had already put forward. So some of the zones which should keep in mind are the parking, security, the outpatient area, surgical area, inpatients, and all this depends upon how much load you are looking at and the future plans also. The key areas I would consider in any facility, whether how small or big they are the optical area and the operating room. These are most crucial areas, and maximum effort should go into making these areas patient-friendly so that they generate maximum income for you. The outpatient area, I would call my center as a short-stay surgical center. Daycare is an older technology. So in a short-stay surgical center, the patient and the relatives spend maximum time in the reception area. So try to make it as comfortable as possible. And even though you are a single practitioner now, always think that you're going to hire more doctors later, and try to put at least 2 or 3 consultation rooms extra, and make it a point that you interconnect all these consultation rooms so that cross-referrals would be possible. And also consider the optometric cubicles, emergency room, nurse stations, and patient education displays are very crucial. So for a single or a group of practice, I've just formulated the minimum area that is required. Of course, I'm not taking into consideration the corridors. So around, for a single doctor, ophthalmic consultation, you need at least minimum 860 square feet to make the patient look comfortable and not claustrophobic. So the optical area display, as told you, is one of the crucial areas which generate maximum income for the hospital. It takes care of all the running needs of the hospital. So make it in the center of your place where people are made to walk through the place, let them see what they display. So in this way, you can also reduce the staff who are showing the frames to the patients. The patients can walk around, look at all the frames on display, and then they can choose by themselves, something like the supermarket technology. So the investigation area depends upon how many doctors are there in your hospital. If you're a single doctor, then you would not be using all the investigation modalities at one point of time. Why I'm telling you this is, suppose if all your investigations are being used at one particular point of time, you need to calculate your electrical load also much higher, probably 20 to 30% more than what is required. So otherwise, suppose if you plan for a small electrical backup, and as days goes by, you're using more than one facility or one instrument, it will lead to a problem. So try to utilize the space maximum. So now coming back to the operating standards, most of your energy and resource goes into designing the operation theater, because this is something which you cannot renovate later. So give maximum importance to it. These are the standard NABH requirements required for any ophthalmic theater. When we started constructing our theater, this ICAS standards was not there. It was only a basic and general specialty theater which needs 400 square feet and 10 feet height. But now it has been reduced to 260 square feet of operating area. And if you're planning to share this with the general specialty clinic, then it is not possible. You have to go for a 400 square feet with a 10 feet height. The basic factors are to provide a seamless surface, take consideration for the entry and exit, and the lighting and electrical. So whether small or big your facility is, these zones has to be kept in mind: the protective, clean, aseptic, and disposable zone. The basic concept is the microbiological content decreases from outside to decreases from outside to inside, and the positive pressure increases from outside to inside. These are basic concepts which you should keep in mind, however small a larger facility may be. So this video shows you the way we went forward right from renovating a place and how it all featured. Okay, so see, this is the minimum area that is required for a single cataract practice. So I've taken all the protective zones, clean zone, all into consideration. As you could see, the major areas goes to the sterile zone and the protective zone, where you have the recovery beds of minimum 2 beds. So I've not taken into account the corridors in between, but if you put it in a corridor, the traffic flow would be much, much easier. And if you are going to incorporate a HVAC system, these are the minimum square feet that is required to put in a hair handling unit, a compressor, vacuum manifold, and a minimum tonnage you required for 260 square feet is a 5.75 tonnage. So these I'm not going to talk on. These are basic things on how a protective zone, clean zone looks like. I'll skip all these slides. So I'll give a short note on the theater sterile supply unit. You should understand that though you are not going to function in this area, it is your staff who is going to function here. And it is all recorded that the temperature inside the sterile supply zone can even reach up to 85 degrees Celsius, and the humidity goes to 160. So try to make your staff comfortable by installing an HVAC system even for this, at least the minimum air changes of 10 per hour. Zoning is also important in a sterile supply unit, where you have to have separate zones to receive the instruments, clean them, pack them, store them, or again re-autoclave them. So this is the chain of facility where I have installed a distilled water plant and a high flow air gun, which is very essential to clean hollow instruments which you use in our practice. And the basic thing is the vertical autoclaves are not used anymore. The best one is to install a horizontal double door autoclave if it is possible to put it in your setup. And this is a horizontal double door autoclave with a data logger, with all your records get stored in the computer. You need not record all this until you get a legal problem. When the legal problem comes, they ask for all the records, and when you're going to show your computerized records, it adds more practice in the court of law. So this is the other end of the double door autoclave, where it opens up into the clean zone and it goes directly into the sterile zone. So the non-medical and medical points are important for a doctor to know this. And see, the principal points are civil, what you're going to use to cover your roof, your walls, or your floor, the ventilation or the HVAC system, the biomedical chambers, and so on. So basically, you have a lot of goods to choose from to cover your walls. Either you can use the modular OT, depending upon your cost. You can either use an aluminum, PCGI, or stainless steel. You can use the stones, as Sir has said, either granite or the Kota stones, or simple vitrified tiles. I would always suggest an stainless steel for your roof, because this area you're not going to clean very often, and stainless steel by itself is bacteriostatic. And see, this is what you see. Most of the hospitals I visited before I went into this project are at the end of the operating room. You'll find the return adducts coming outside. So in a place where there's already a space constraint, what we planned was we embedded all the return adducts into the 9-inch wall, so that even that little amount of space will help you later on. And make sure you paint these inaccessible areas with antifungal polyurethane foam paints, which prevents microbiological growth later on. And make your the edges of the walls coved. You can either use the plastic, stones, or metals, depending upon what kind of budget you want to allocate for that. Your doors has to be at least 6 feet height and 6 feet, so that you could wheel in your patients during emergencies. You might think that you would not have an emergency at all in your place, but believe me, it can happen anytime. Last month, we had a death in a facility, and we did all that we can, but what happens beyond that is beyond your control. So try to have your facility designed to handle all these emergencies also, because the patient attenders are looking at everything you are doing. And suppose if you have say a code blue in your hospital, and if you're not able to wheel the patient out, all this adds against you in your court of law. So the SS roofing or the false roofing is very important in any healthcare facility so that it clusters all the ducts and the electrical wiring above. This you have to plan earlier. If you're planning a 10 feet height, your RCC slab has to be cast at around 12 feet. So this and all you have to tell your architect who is not having a prior knowledge about designing an hospital. So the ventilation system I would call the mother of your main theater, and these are the standards which are available according to NABH. This is the flow chart which we follow, and the basic components of an air handling unit. Most of the doctors don't know what the air handling unit. There was one accessor, NABH assessor who called me from a 3-tier city. He said, an HVAC consultant had installed an AHU box without a pre-filter in it. So the doctors, unless they have a knowledge of what an AHU is, it's very difficult for you to bargain on the cost also. So the AHU, the air handling unit, the compressor, and the laminar outflow forms the HVAC system. If you go to the interior of the air handling unit, you have 3 chambers. The first chamber draws fresh air. The second chamber cools the air. And the third chamber blows this air into the theater. This Kruger-Hall-Breuer is very important because, you have a car, and in the car you can go at 10 kilometers per hour, and you can also go at 100 kilometers per hour. So it depends on your use. So when you install a higher-end air blower, you can change the air changes either 10, 20, or even 80, depending upon your need. So when you're going to bargain with the HVAC consultant on this, he would simply reduce the efficiency of the blower. The efficiency of the blower depends, just like a ceiling fan, you can regulate the regulator and make the air changes possible. So this is the laminar airflow, which shows the air coming from the ceiling and going in a unidirectional flow to the ducts. The water quality also has to be considered when building a hospital. You have to follow the ISO water quality standards, and the most simple way of doing it is installing an RO water plant, which not only makes the water bacteriological free, but also reduces the salt in it. So this is the water test which we did before installing an RO plant and after. The main culprit is the hardness of water. You could see how much the hardness of water has decreased. But also consider that the major source of water to be used in an ophthalmic facility has to be only a distilled water, because it makes the dissolved salt 0 and also increases the life of your equipments. And we also have a terminal UV filter. We don't use boiled water to wash our hands before you go for surgery. I basically get a separate line from the RO plant to a terminal UV filter, and we wash directly from the faucets. But however, you have to have repeated water cultures to make sure that this is bacteriological free. The biomedical control waste control is very important. For smaller setups, you need not construct a plant. You can have a separate line which takes all the water from the theater into a separate chamber, which is disinfected and then let out in the main sewage. The electrical points are also very important. Calculate the wattage you need for every equipment you're going to put. Add 20% more, and then decide on the wirings you're going to put and the backup power. The IP64 grading lights are also there, like the ISO grading. The IP light, so the lights used in a healthcare facility should be IP64. That is ingress protection, which is dust and water repellent. Most of the times in the older facilities you go, the tube light doesn't function because of your fogging. So always consider using IP64 lights. So this is the feature of the IP64 lights, where you would see everything is sealed up. If you want to install an surgical pendant, if you're doing orbital cases or other cases, this has to be installed right in the time when you install your RCC slab itself. So electrical source of power should be kept in mind. See, inverters for everything which is above your head, and anything below your hip, you go for the UPS online power and raw power also. This is the surgeon control panel. Though it is not mandatory, it serves a lot of, reduces a lot of headache for you. So you make a big opening in the RCC slab, in the wall, and one end I have fixed in a stainless steel which encouses all the your electrical recording equipments, your power regulators, everything. And so that this clusters all the wire, nothing is hanging on the wall, as you could see here. The other end could open into the clean zone, where the protective zone, which helps the technicians to take care of any technical issues later on, so that your technician need not go into the theater while handling or servicing these equipments. As I told you, make your toilets differently abled. You have to have wide opening doors, rails around, and also an alarm bell inside the toilets in case they fall. They need to call you. These doors should not be locked from outside. They can be only locked from inside. And fire exits, see, according to your local requirements in your place, kindly follow those principles. The manifold and anesthetic requirements are usually neglected in any small healthcare facility. Try to implement them as much as possible. And finally, whatever are done has to be validated by a third party. The main thing is your OT validation, which validates all this to make it operable. Thank you.